This is velocity time graph. It is used to describe a uniformly accelerated motion. Can you explain this graph? Welcome to Knowledge Base. In this video, we are going to describe a uniformly accelerated motion using this velocity time graph, and we are going to demonstrate how to use this to solve problems under uniformly accelerated motion. If you are coming across our videos for the first time, please endeavor to click on the follow button and follow our page. Please like and share this content to others so that they can learn exactly what you're about to learn from this video. And most importantly, drop your comments in the comment section. If you have any question, any challenge, I'll be waiting in the comment section to answer your problems. But for now, please enjoy this video and understand what velocity time graph is. This velocity time graph, like I've mentioned before, is used to demonstrate a uniformly accelerated motion. It is called velocity time graph because it is a graph of velocity plotted against time. In this motion, the origin is point A. I'm going to describe this using a car. So we're going to assume that the car starts from rest, beginning at the origin, point A. Then the car starts moving, it means it starts increasing in speed. That period where the car is increasing in speed is described as the acceleration. So the car increased in speed from point A, accelerates until the speed gets to point B. Hence, BE, when extrapolated to the vertical axis, represents the velocity the car has reached over a period of time, AE. So, BE is the velocity, AE is the time taken for that increase in velocity to take place, while the slope AB demonstrates or describes the acceleration of the car. So we can say the car accelerates from rest until it reaches a velocity B over a period of time AE. This is the first phase of the journey. At point B, or between point B and point C, over the period EF, the car maintains its velocity. It means it is no longer increasing in speed. It just maintains that speed it attained at point B. What it means is that there is no longer slope between B and C. Between A and B, you could see a slope demonstrating acceleration. But between B and C, there is no slope. It is just flat, meaning that there is no more acceleration. And this point is described between B and C as the period of what? Uniform velocity. It means this velocity is maintained. Therefore, there is no acceleration over the period of time, EF. This is the second phase of the journey. Now the car wants to come to rest. For the car to come to rest, you apply the brakes and then the car starts slowing down. So between C and D, the car starts reducing in speed gradually, slowing down until it gets to a final speed of 0. This slope CD, which is the slowing down slope over the period FD, is described as the deceleration of the car. In other words, the car is slowing down. It is changing in speed decreasingly. It is retardation, or you can call it negative acceleration. So at this point, the speed changes from C, formerly B, down to point 0 at D. That change in speed is described as CF over a period of time, FD. This represents deceleration phase of the journey, and it is the third phase of the journey. So we describe the uniform motion by the graph A, B, C, D. So A, B, C, D, which is a trapezium, is used to demonstrate uniformly accelerated motion. Kindly note that velocity time graphs are not always represented like this. They are different form. but this is the most basic and typical representation of velocity time graph. Now that we've known what is happening in this graph and the motion as demonstrated, how do we use this to solve problems? Let's look at the first phase of the journey, the acceleration phase, represented by this triangle ABE. The distance covered during acceleration is given as S1, and that is simply equal to the area of this triangle ABE. So we can say that first acceleration AB is equal to the slope of the graph, which is BE all over AE. BE all over AE. So if you're given two of these sides of the triangle, you can find the third side, be it the acceleration, the velocity, or the time taken. Similarly, deceleration is given as CD equal to CF all over FD. You can find any side of this triangle using this formula. Remember, it is the slope that is the deceleration or the acceleration, not the magnitude of this line. So you are not using Pythagoras theorem, you are solving the slope, which is the change in the vertical divided by the change in the horizontal. Now for the first phase ABE, the area of the triangle equals to the distance covered during acceleration. So distance covered during acceleration S1 is equals to area of triangle ABE, and that is S1 equals to half base times height. The base is AE and the height is BE. During the period of uniform velocity, the distance covered is S2, and you will agree with me that this is a rectangle, and that will be the area of this rectangle. Area of rectangle BCFE, BCFE, and that is equal to length BE times EF. BE times EF. We know that the length times the breadth is the area of a rectangle. And similarly, finally, the area of this triangle represents the distance covered during deceleration S3, and that should be equals to half the base FD times the height CF. The final thing we want to look for is the total distance covered during the entire journey. The total distance covered during the entire journey typically is equal to S1 plus S2 plus S3. That gives you the distance covered, or you can obtain it by finding the area of trapezium ABCD. ABCD is a trapezium. Once you find the area of this trapezium, you also obtain the total distance covered. So we can say that the distance covered during the entire journey S is equal to the area of trapezium ABCD. ABCD. And that is equal to half the sum of the parallel sides of the trapezium times the perpendicular height. The parallel sides are BC and AD. They are parallel. So the sum of the parallel sides, half of it, times the perpendicular height, BE. It could be BE, it could be CF, because they are the same value. So you can say BE is the perpendicular height or CF is the perpendicular height. So these are the formulas and how you can use a velocity time graph to solve problems under uniformly accelerated motion. I hope you enjoyed this video. If you enjoyed it, please share this video to others so that they can learn from this page, and kindly click on that like button to keep encouraging us to make interesting contents, and please follow us and see you in our next video. Thank you for watching.